Hello everyone, unit 6 lesson 2, where we are introduced to our methods of factoring. Now, factoring, they have noun and verb. I know it's not an English class, but when we say factor, it could have different meanings. So if it says factor this polynomial, it means to rewrite a quantity as an equivalent product. So you would factor it and be the same. Or we could say, what can you factor out of this polynomial? So that's an individual component or individual term that will come out of your polynomial. So we just need to know the context that we use the word in and what we're looking for. In exercise 1, they talk about prime factorization. So with prime factorization, these are values that could be common in a binomial, a trinomial, any polynomial. But it doesn't only have to be prime. But sometimes it helps to bring out one prime number and see if there's another one that is one of the factors we could take out. So if we list the prime numbers, we would start like a 10 or 12. How do we find factors of 12? Factors of 12 are 4 times 3. Well, 4 is not prime, but 3 is. So then 4 breaks down to 2 times 2 times 3. And so that's the prime factorization. When you go to 30, it's 10 times 3. 10 is 2 times 5 times 3. So you keep breaking it down until you get all prime numbers. Now remember, 1 is not prime. Okay? So it's any number that's only factors are 1 and itself. 16 breaks down to 4 times 4. The 4 breaks down to 2 times 2, and then the other 4 is the same, 2 times 2. Now, you can do it many different ways. 16 could have been 8 and 2. Then you would just have to keep breaking down the 8, as long as you get all prime numbers. And then 36, 9 times 4. 9 is 3 times 3. 4 is 2 times 2. And that's the prime factorization. They're not going to ask you that question on the Regents exam. Oh, what's the prime factorization of this? But you may need to apply it when you're factoring or when you're choosing a GCF. So when we get to exercise 2, now we're starting with the binomials. So we want to rewrite each of these following binomials as a product of an integer with a different binomial. So sometimes they ask you, or they use math terms, and you just have to make sure you're familiar with them. Now this is all based on that factor flow chart in the front of the room. The first thing you always look for is a GCF. So when I look at these values, 5 and 10, can I take something out in common if you were to do a prime factorization? Well, I could take out a 5. So therefore, I'm left with an x plus 2. Because you want to be able to redistribute that 5 and end up with the original binomial that you started with. And you always want to take out the largest because they're going to want you to factor completely. The next one, we have 2 and 6. The largest that we could take out is we could take out a 2. And you're left with an x minus 3. So that way, if you redistribute, you're back to the 2x minus 6. 6 and 15. Well, you can't take a 2 out because they're not both even. Can you take a 3 out? Yes, you can. So you can take a 3 out, you're left with a 2x plus 5. And that's as far as you can go. Okay, because you have to be able to take it out of both terms. The 6 minus 14x, I could take out a 2, and it has to be in the right order. I have a 3 minus 7x. Be very careful with the order. If you want to change them around, you can, but then you got to be careful of signs. So if you rewrote that, it would be negative 7x plus 3. Now, it's not only leading coefficients that can be factored out. You can also factor out variables. So if every single term has a variable, you can take that variable out as a GCF. So we want to rewrite these a little more complex. So first we look at the leading coefficients. So we have a 3 and a 6. We could take out a 3. Then you look at the x's. I have 2 here, I have 1 here. The maximum amount I can take out is 1. So I have a 3x. So what do I need to get me a 3x squared? I need an x. What do I need to get a 6x? I need a 2. So you have 3x, x plus 2. So that way if I redistribute it, you are back to the original binomial. Letter B, the 20 and the 5, I could take out a 5, 1x, 2x, so I could take out an x. And I am left with 4 minus x. So that way, if you redistribute, you are back to the original binomial. So you have your 20x minus 5x squared when you redistribute. When I get to letter C, I have a 10 and a 25. The greatest common factor of 10 and 25 is 5. Again, 2 x's and 1 x, so I have an x. Therefore, I'm left with a 2x plus 5, and that's factored. The last one, 30 and 20, I take out a 10. There are 2 x's here. There are none here. So don't force to take out an x. You don't have to. So I have a 10. I'm left with a 3x squared. Be very careful. Minus 2. Okay? So just be careful with this factoring. And the GCF, it's always the first thing you look for, and sometimes the students forget about it. Okay? So always make sure you're looking for a GCF. And it could be a multiple choice. And equivalent, so take out 20 and 36. You got to be very careful. You could take a 2 out. So let me just show you what happens here when you take a 2 out. So I take a 2 out, and I'm left with a 10 minus 18. I didn't do the x yet, so they're just blank. Okay? Now, do you see that these are still even numbers? So I could take out another 2. So you took out a factor, but you didn't take out the greatest common factor. So your greatest common factor would be 4 of the leading coefficients. Now the x's, there's 2 here and 1 here, so I can take out an x. So I have 4x. Now to get back to the 20x squared, I need to multiply by a 5x, and there's your minus, and the 9 to get me back to the 36x. So 4x times 5x minus 9, which is choice 2. Okay? Same thing with trinomials. Take out a GCF. But this time, we are looking at all 3 numbers, 2, 8, and 10. The largest I can take out is a 2. There's 2 x's here, 1 here. There are no x's here. So you can't take any out. So then you're left with x squared plus 4x plus 5. And that's it. That's factored. That's as far as you can go for now. Next one, you have 10, 20, and 5. Good. I was looking for an example like this. So we can take out a 5. Again, 2 x's, 1 x, no x's. So we have a 2x squared minus 4x. Now this is where some of the students get tripped up. It's a plus 5. So if I have 3 terms originally, I have to have 3 terms in this parenthesis. So you have to have a plus 1 to get you back that 5. Now letter C, I have an 8, a 12, and a 20. 2 goes into it. 4 goes into it. And that's about it. Okay? So 4 into all 3 of them anyways. So there's your 4. Now we have 3 x's, 2 x's, 1 x. This time we can take out an x. So we have 4x, and then you have 2x squared to get you back to the 8x cubed minus 3x plus 5. Okay, and that's taking out just the GCF. All right, if you need to pause it or whatever, go ahead. I'm going to make some room. Okay. Now the last one, a 6, a 15, a 21. You can't take a 2 out because they're not all even numbers. You could take a 3 out. You can't take a 6 out, so you could just take a 3. Again, x's and x's, so I can take out 1x. So 3x, I'm left with 2x squared plus 5x minus 7. So again, you're taking out such that when I redistribute, I end up with the original polynomial. Okay, so that's the first method, is your GCF. The second method is a difference of 2 perfect squares. Conjugate multiplication pattern. I'll never call it that. I'll always call it the difference of 2 perfect squares. Okay? And if you start with this, x squared minus a squared, it equals x plus a, x minus a, or x minus a, x plus a. Either order is fine. The key thing here is you need to be able to identify perfect squares. 1, 4, 9, 16, 25, 36, 49, 81, on and on and on, 100. Okay, you should be able to recognize them. Here, letter A, I have difference, and I have two perfect squares. So then it's x plus 3, x minus 3. If you do it the other way around, that's fine. X minus 3, x plus 3, no big deal. Now you got to be careful. Okay, whatever comes first has to stay first. 4 is a perfect square. 2 minus x, 2 plus x. Okay? In letter C, a little more complicated because you have a 4 and x squared, which breaks down to 2x and 2x. And then plus minus, minus plus, it doesn't matter. The 25 is 5 and 5. Okay? Letter D, 16 is a perfect square, so you have your 4 and 4. Plus minus, 81 is 9 and 9. X squared is x and x. Okay? As long as you have an even power of x, that could be the perfect squares. Okay? And we get to the next part with fractions. 1's a perfect square. 4, 9, 81, 49. They're all perfect squares. So how do you show this? X and x plus minus. Square root of 1 is 1. Square root of 4 is 2. Okay? They're the exact same numbers and variables, except there's a plus and a minus. Here, 25 is 5 and 5 plus minus x over 3, x over 3. Okay? So you see how they're the same terms, just different signs. And then the next one, 4 is 2, 81 is 9, and you have an x plus, and then the 2, 9x plus minus, square root of 49 is 7, square root of 9 is 3. 7 over 3. A little more complicated. Okay? And then the last one, D, square root of 36 is 6. Square root of x squared is x, and x plus minus square root of 49 is 7. Y squared goes to a y. Okay? So that way when you redistribute, if you box it up, you will be left with the original binomial. Okay? And then the last few, we have to take a GCF first. So you always look for a GCF. So 5 and 20. Take out a 5, I have an x squared minus 4. Now you have to be able to recognize that that's a difference of 2 squares. 5x plus 2, x minus 2. Okay? The next one I could take out a 7. 4x squared minus 1. Don't lose that minus 1. So then it's 7, 2x plus 1, 2x minus 1. Okay, and that's factored completely. Now this here, 40 and 250. Okay? A little more challenging. Okay, start with the easy one. Start with 10. Okay, 4 minus 25x squared. All right, so that's good. That's as far as you can go. Okay, but that was easy. You could have taken 2. You could have taken 5. Okay, but the largest you would have been able to take out was 10. So then you have a 10, and then you have a 2 minus 5x, and a 2 plus 5x. Okay? And then letter D, I could take out, be careful here, I have x's in both terms, so I took out a 3x. I'm left with an x squared minus 16. So then I have 3x, x plus 4, x minus 4. Okay? So we had a GCF and a difference of 2 squares. Okay? Always look for a GCF first. If you have a difference of 2 squares, you only have 2 terms. They're being subtracted, and they're both perfect squares. Okay? So if you have any questions, ask tomorrow in class. And we're going to do a lot of practice with these in class. Okay? So be ready to roll. All right.